question is, what do we do if there's a coefficient in front of the x squared in a quadratic trinomial? And my pledge is that we're not going to answer this question in its full generality, because it would take us further afield than I want to go. There are certainly other algebra classes on our campus that do. My evening class certainly does. The problem is that not only then do we have to balance the needs of finding two numbers which multiply together to give me negative 72, we also have to find two expressions which multiply together to give me 4x squared. And the problem with that is that unlike the previous example where we could just get away with doing x and x, now we have to decide whether it should be maybe 2x times 2x to give me 4x squared, or even 4x times 1x to give me 4x squared. So that gives us sort of one more uncertainty in how we factor this expression. But I chose this example specifically because there's a way that we can avoid that problem in factoring this particular expression. And the way is as follows. Before we start thinking about factoring using trinomials, before we think about 5.2 section material, what about 5.1? Do the terms in this quadratic have a greatest common factor that would help us to factor out? What do you see? But when we look at these three terms, we realize that they all have something in common, something useful in common, not just one. They all have a 4 in common that we can factor out. And factoring that 4 out might, and in fact will in this case, help us to avoid the question, what about that coefficient in front of the x squared? Once we've factored that 4 out, it won't be in front of the x squared anymore. It'll be off doing its own thing. So let's use this as an opportunity to factor out the 4, which is the greatest common factor of these three terms, and then see where that leaves us. So if I factor this 4 out, what's going to be left inside the parentheses? What's going to be left in the first term after we factor out a 4? It belongs here. X squared. If I factor a 4 out of 12x, what's left over? And if I factor a 4 out of 72, we saw in our factor tree what's left over? 18. And now we've reduced the original problem down to one where if I want to continue factoring, what I have to factor is instead x squared minus 3x minus 18. So we've taken care of that coefficient in front of the x squared problem. And we can focus on x squared minus 3x minus 18. How can we factor that thing written in orange? What are we looking for? What do we need to find here? Yeah, we need a pair of numbers which multiply together to give me negative 18 and which add to give me negative 3. So if you like guessing and checking, and I think this is how your book kind of recommends beginning the process, start thinking about what pairs of factors multiply together to give you negative 18. So a simple example is negative 18 and 1. What are some more examples? How else does 18 factor? 9 and 2. What else? 6 and 3. If we try to get any smaller, I think we just end up repeating ourselves, but let's continue doing it anyway, because in addition to putting the negatives where they are, we also have the option to put the negatives on the other numbers. So negative 3 and 6, negative 2 and 9, and then negative 1 and 18. So here are all the different possibilities for numbers that we could multiply together to give us negative 18. Those numbers are going to be what fill in the constant terms here and here, right, in our ultimate unfoiling factors. Which pair do I want to choose? Yeah, what does it have to add to in this example? Negative 3, the coefficient of the x. So this has to be our sum, and this has to be our product. So, which pair of numbers, which pair of paired factors for negative 18 add together to give you negative 3? Negative 6 and 3. Whoops. That's the pair that we're looking for, because negative 6 plus 3 is negative 3. So that means that negative 6 and 3 are going to be what I put in these boxes when I unfoil. Right? And you don't have to use this little grid if you don't want to. This is just how I keep my stuff straight. And because we know we need an x squared, that means that the other terms are x and x, because x times x is x squared. And that makes the other terms negative 6x and 3x, which confirms our desire to add those terms together, negative 6x plus 3x, to get the negative 3x from the original. And so according to all of that, how, therefore, does the factor x squared minus 3x minus 18 in orange break apart? What does it break into? X plus 3 and x minus 6. And so if the original question were to factor the quadratic written up top, 4x squared minus 12x minus 72, I would first have asked, is there anything I can do to get a greatest common factor out of those three terms? In this example, the answer was yes. We can bring a 4 out of everything. Once we bring the 4 out of everything, then what's left over is a trinomial that we can factor using the sum and product game, which when we do, we end up factoring it into x plus 3 times x minus 6, and therefore a factorization of the original expression is 4 times x plus 3 times x minus 6.